All right, let's get started on the 5.3 ready. Its topic is congruence statements and corresponding parts, and matching those up. Remember that when you write a congruent statement, like triangle ABC and FGH, the corresponding parts of the two triangles are the parts that are congruent. So like A is congruent to F. See how they're both in the first place? AB is congruent to FG because it's the first two letters and the first two letters. B and G because it's the second two letters, etc. Recall that the congruence patterns for the triangles, angle, side, angle, side, angle, side, 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 and angle, angle, side, which is another form of this one, are what we use to justify triangle congruence. And the segments and angles in each problem below are corresponding parts of the two congruent triangles. So we're going to make a sketch of the two triangles and then write a congruent statement. So real quick, you need to make a little tiny triangle for each of these. So draw yourself some little triangles for each of these. And we don't have a lot of space, so I'm making them tiny in between. Okay, so looking at the first set of triangles, it tells us that ML is congruent to ZJ. So in the first triangle, I'm making ML on the left like that and to the right. So that's the first side. And then I'm going to make ZJ corresponding in the other one. So do you see how so far I know where those two things are? And then LR is congruent to JB. And angle L and angle J are congruent. So now I can make my congruence statement. Triangle MLR is congruent to triangle CJB by side angle side. Okay, pause the video, try the next one. All right, let's see how you did. WB is congruent to QR. BP is congruent to RS. And WP is congruent to QS. So I can now say triangle WBP is congruent to triangle QRS. And that one's by side, side, side. That's what they gave us. All right, so for the next one, it's telling us for number 3 that CY is congruent to RP. CY, RP. And EY is congruent to BP. And angle Y is congruent to angle P. So I see a side angle side there. So we can now say triangle CYE is congruent to triangle RPB. All right, the next one says BC is congruent to JK, and BA is congruent to JM. And angle B is congruent to angle J. So there's another side angle side. So now we can say triangle BCA is congruent to triangle JKM. Now, could you be doing these in a different order if you're reading them yourself and not using this video? Absolutely. There's other correct orders for these. DF congruent to XZ. FY congruent to ZW. And angle F congruent to angle Z. A lot of side angle sides. So triangle DFY is congruent to triangle XZW. Finally, number 6, WX is congruent to AB. XZ is congruent to BC. And WZ is congruent to AC. So triangle WXZ is congruent to triangle ABC. You got it. By side angle, side. 3 sides. Okay, so those are just matching corresponding parts of triangles. Let's look at what's next. Here it gives us a couple definitions that we've gone over in class, but just read those if you need a quick review of what's what. Now it says to name a segment of GHM that is an altitude. So I'm going to highlight this word here. Altitude would be from the vertex to a perpendicular. So I'm going to use that green one there. ED is an altitude of that little triangle. Oh, wait, GHM. Sorry, it wants the big triangle. So I can't do the little triangle. So the altitude of GHM is this guy right here that forms the perpendicular. See how the altitude could actually seem like the outside of a line? Like the edge of the triangle? So that would be GH. Okay, angle bisector of GHM. EG. And a segment that is not an altitude. So like, I don't know, that's a segment that's not an altitude, GM. Create a perpendicular bisector by marking 2 segments congruent to GHM. Name the segment that is now a perpendicular bisector of GHM. Okay, so I think this right here, there's the 2 segments that are congruent, and perpendicular bisector is this guy right here. So name the segment that is now a perpendicular bisector, ED. Okay. Next, it's asking us to do constructions on this triangle. And guess what? We don't have a compass at home. Actually, some of you do. So you could do this from home. But we're going to be doing this in class because most of you don't have a compass at home. And then finally, we're down here to things that we're being told that we know. ED bisects. So I'm going to start marking the picture here. BE and EC. BE and EC, definition of bisect. GE is parallel. GE is parallel to AD, so let's mark that. GA and ED, so let's mark that. Parallel. AD is contained in AC, so AC is also parallel. So this whole thing right here, this is parallel to this because it's contained within. GA is contained, so it's also parallel. So this right here, this whole segment here is parallel to this because it's contained within. BC has the same slope everywhere because it's a line, okay? Angle BE makes with GE must be the same as angle EC makes with AC. BE makes with GE. So this angle here has to be the same that EC makes with AC. Okay, so I'm going to go make that. Okay, and that's this part right here. Since those two segments are parallel, those are corresponding angles. Okay, so BEG, okay, I just marked that, is congruent to ECD. Okay, I just marked that. I now know that I have an angle aside and an angle congruent to the corresponding angle side angle. So I have this triangle congruency by ASA. Okay, so this here is like the thought process. Use Tehani's I know statements and her reasons to write this into a formal 2-column proof that proves the triangles. Begin your proof with the givens and what you're trying to prove. So quadrilateral is a rectangle given. ED bisects AC was given. Hang on. I'm going back up here to the rectangle. ED bisects BC. And then she's wondering if she has enough information. Okay, so if we were told ED bisects BC, she now said, I know that BE and EC are congruent. And so what are we trying to prove? BGE is congruent to EDC. Okay, so it's like I'm going to be using that side. I'm going to be using that angle. So if we know that's 90, I wonder if we could use that to get those two missing angles. All right, I just noticed my video is getting a little bit long, so I'm going to go ahead and just put these images in here for you to follow along from the I know statements into the proof. So you'll see that you start with the givens because they're bisected. Then you can say those two segments are equal by definition of bisector. Because those lines were parallel and rectangles are parallelograms, you can then talk about the two corresponding angles. Then you have enough for congruency by angle side angle. Okay, so you can pause it on that. I'm also going to input the construction here for people who might be doing this from home. Otherwise, the rest of us will be doing it in class, which is totally fine to turn it in without it done. Okay, there's that guy. All righty, that's video number 1.